Okay, we're going to have to do 5.7 in 3 parts. First, we're working with the fundamental theorem of algebra, which basically says if I have a polynomial of degree 3, it will have 3 zeros. So how many solutions are zeros? In this case, there would be 3. And this is to the 4th. The degree is to the 4th, so we'll have 4 zeros. Simple enough. So I want to find all the zeros. This is a little bit repetitive from 5.6, but we're going ahead and keep doing it. Practice will improve our skills. Again, we don't know where to start, so I'm going to say use your graphing calculator or GeoGebra and identify 1 0. And when I graphed this, I found out that it looked like -3 was a 0. So do my synthetic division or substitution, sort of interchangeable. 1, -3, 1, -3, 4, -12, 4, -12, 0. Now this gives me an x cubed, x squared, x. This would be difficult to factor. So I also noticed that -1 looked like a 0. So 1, 1, 4, 4. Now that I've already factored out this x plus 3, so this is the polynomial I'm left with. So these are the coefficients I use. 1, -1, 0, 0, 4, -4, 0. And now I'm down to something I'm a little more comfortable with. So this will give me x squared plus 0x plus 4. So far I know x plus 3 is a factor, and I know that x plus 1 is a factor, and then I have x squared plus 4. Now this one is hard to figure. I mean, you can't factor this. If we had x squared minus 4, we would know that's x plus 2, x minus 2, because the inner term cancels. But an x squared plus 4 can't do. So here we would have -3 would make this 0, -1 would make this 0. And if I do x squared plus 4 equals 0, and I subtract 4 from both sides, I get x squared equals -4, and this brings back our old friend, plus or minus, because I'm taking the square root. Square root of 4 is 2. Square root of -1 is I. So plus or minus 2i. And imaginary roots, imaginary zeros, always come in pairs. So I have 4 zeros. This was an x to the 4th. -3, -1, and then plus and minus 2i. Okay, that's that one. Here's another function, x to the 4th minus 2x cubed minus 3x squared plus 2x plus 2. And again, when I graph it on my calculator or GeoGebra, it looks like 1 is a 0. So 1, -2, -3, 2, 2, 1, 1, -1, -1, -4, -4, -2, -2, 0. And again, this would be complicated to try to factor. So I look again, and it looks like -1 is another 0. So I use what I've narrowed down to. 1, -1, -2, +2, -2, +2, 0. And again, I'm down to a trinomial, x squared minus 2x minus 2. So I know that x minus 1 is a factor. I know that x plus 1 is a factor. And then I have x squared minus 2x minus 2. And I can't factor that, and I can't just set it equal to 0 like I did with x squared equals -4. So this time I have my old friend, the quadratic formula. A is 1, b is -2. C is -2, so x equals -b plus or minus the square root of b squared minus 4 times a times c. So that's going to be a plus 8 all over 2a, which is 2. So x equals 2 plus or minus the square root of 12 all over 2. And x equals 2 plus or minus, this is 4 times 3, so that's 2 root 3. Each of these is over 2, so I get x equals 1 plus or minus root 3. So my 4 zeros are x equals 1, x equals negative 1, x equals 1 plus root 3, and x equals 1 minus root 3. Imaginary zeros always come in pairs, and irrational zeros always come in pairs, conjugate pairs. So we're going to stop that one right there. That'll get you through the first couple.